So here's another application problem. The last one might have been a little confusing, but we'll try again here. So it says tension, that's what it looks like to me anyway, I think it's a person's name, needs to eat at least an extra 1,000 calories a day to prepare for running a marathon. He has only $25 to spend on the extra food he needs and will spend it on 75-cent donuts, which have 360 calories, and $2 energy drinks, which have 110 calories. Okay, so we have two things going on. He has so many calories that he needs to get. Calories. And he has so much money. How much money does he have? I don't know that he should be eating donuts and energy drinks, but we'll skip over that part. Okay, so he needs to eat at least an extra 1,000 calories a day. Okay, so each donut, and this time I'll go ahead and use X. So if you didn't understand the last one, I'll use X for donuts, and so donuts, and I'll use Y for the energy drinks. So it's 110 calories for each energy drink. And it says he has to get at least an extra, so greater than or equal to 1,000. Okay, money. Now let's talk money. So he's getting, it costs 75 cents for each donut, and it costs $2 for every energy drink, and he only has $25 to spend, so it's got to be less than or equal to $25. Okay, so some crazy things going on here. Okay, so let's see what we can do to make these equations work a little better for us. So I have 360x plus 110y has to be greater than or equal to 1,000. Now I can divide by 10, so 36x plus 11y greater, oh, dang it, I did this last time. I got to make these equations. We're graphing equations. Equals 1,000. Okay, equals 100. Okay, so kind of large on the numbers here. Let's see what we can do to make things more reasonable. Those are the numbers they give me. Well, yeah, I was hoping things would just work out a little bit like some integers, you know, kind of thing, but I'm not getting that. So let's make a table of values, see what happens with a table of values. If I make a table of values, I'll put it over here because it's going to take me some room to do this. So let's say I buy 2 donuts. And then that's going to be, what, 78? So I get 11y equals, so I picked 2, right, for x. Let's see, 22. Ooh, I'm getting lucky here. And really, this was luck. I just happened to pick a number that worked nice. Honest and truly, that was just luck. Okay, so I have 1 point that will work. So I got 1, 2, 2. Let's see what else would work. I don't think 1's going to be a good one to pick. Well, I've got to pick something, right? Okay, so we're just going to get some kind of decimal thing going on. 36 doesn't go into 100 evenly, and neither does 11, so that's why, like, darn. Okay, so we'll try a 1 for x and see what we get. So 36. Going to take up all my room. I'm thinking it's going to be 64. So what's 11 into 64? Well, it's going to be approximately, we're going to go in evenly. So let me do this on the calculator. It's about 5.8. Okay, so we put in a 1 for x, and we got 5.8. Now, you can put in a 3 for, well, let's go ahead and do that. put in a 3 for x. So what's 3 times 36? Oh, that's too big, isn't it? Okay, you can't have 3 donuts. All right, so that's going to be too big. Well, you can put it in, though. This will be interesting. Okay, let's do the math part here. I'm running out of room to write. 36 times 3 plus 11. Why? I mean, deep down we know we can't have a negative number of energy drinks, but let's see what happens when we get this. You get 108 plus 11y equals 100. So 11y is equaling negative 8, or approximately negative, what's 8 divided by 11? 7.2. I'm sorry, about 0.7. Okay, so let's go ahead and put that, negative 0.7. Okay, let's graph these and see if they line up. 2, 2, right there. 1 and 5.8. 1, 2, 3, 4, 5, 6, 7. About there. And then my other one, 3 and down here. Kind of. Do they look like they line up? Pretty good. So mathematically, we can say, well, we'll have a negative number of energy drinks, but in reality, you can't do that. So, okay. Now, if you put in 0, 0, is that going to work? And I ran out of room, but 0, 0. And we're using this inequality, 360x plus 110y. It has to be greater than or equal to 1,000. So 0 is not going to work, right? 0 is not greater than 1,000. So it's got to be over here. He's got to have at least 1,000 calories. So points over there, combinations of donuts and energy drinks. Okay, now we'll go to the other one and try to graph that. I'll write it down first. Okay, so 0.75x plus 2y is equal to 25. So we'll start with that. What I really want to do, got some crazy numbers here, is make that 0.75 a fraction. So 3/4 x plus 2y equals 25. So 2y, I'm going to put it in slope-intercept form, negative 3/4 x plus 25. Now the bad news is I have to divide these by 2. So, it's like multiplying by 1/2 in there. There's some crazy numbers. Anyway, negative 3/8 x plus, and this is going to be 12.5. Okay, so, and it's kind of off my grid here. But 12.5 would be like up here someplace. Maybe I don't like this way of doing it. So if I go down 1, 2, 3.5, and over, well, I gotta go negative 1, 2, 3, 8. Like over here. Okay, well, I'm getting it to be something like this. Need to extend my blue line. Okay, now if you just focus on the green line, will 0, 0 work? Yeah, because if he doesn't spend any money, that's going to work. So down in here, whoops, green. So you get this little area right in here of possible donut energy drink combinations that will satisfy the conditions. Okay, can he buy 8 donuts and 4 energy drinks? So 8 donuts, 4 energy drinks, 1, 2, 3, 4. So this point right here to satisfy his caloric needs. Yeah, he can. So yes, it's in the yellow area, so it looks good. Can he buy 1 donut and 3 energy drinks? 1, 2, 3. No, that does not look like it's going to work. So again, you might say, well, I don't know that your lines are so straight. You could plug them into the inequalities and see if they actually work, see if they are solutions, okay? But I feel pretty good about my graphs here that I'm okay. All right, that one was a little different.